Welcome to China Manufacturing Decoded from Sofeast, the podcast where we take you through some of the major topics facing importers and manufacturers in China today. Hi listener, welcome along to episode 49 of the podcast. Renaud, our CEO, and myself, Adrian, from the team are going to be talking about NRE costs today. These costs are usually incurred towards the start of a new product development project, especially when you're producing customized products in China or Asia. They normally cover all of the costs that you need to sink into the R&D of your product. So that could be the design of some of the components, it might be the design of the mold, and then of course the production of the molds. This isn't something that all Chinese manufacturers, for example, will tell you about, and so you need to know how to calculate accurately the NRE costs so you understand what to budget for and the costs of your product over time. And that's what Renaud's going to take you through in this episode. Hello again, Renaud. Thanks for joining me.
Hey, Adrian. Good to be with you.
Yeah, just to begin the podcast, could you please explain what are NRE costs?
Sure. So let's say you develop a new product, and that product takes some work to develop. Let's say you can just go to production right away. All of the one-time expenses, let's say it's like an investment, right? The one-time investment, the expenses that are not going to be recurring, but that just happen once, and you basically can't really do without them to get your product into production and onto the market. That is usually called NRE, non-recurring engineering costs, and it actually includes more than just purely engineering work. A lot of that is engineering work, but not only. So when you plan for the expenses of your of getting your new product onto the market, you will want to say this is the one-time kind of investment versus this is the unit cost to produce, and then the unit cost maybe to do sales or to do B2C marketing with maybe some advertisements and things like that. So this is quite important because then you need to have some projections about quantity, the number of pieces you're going to sell over a certain lifetime of the product. And if your non-recurring engineering fees, your NRE, the one-time investment is say $100,000, and then the unit cost to produce is $10, and then the full cost of selling it actually and distribution maybe is another $10. Well, you can just sell for, let's say, $20 plus $5 of margin. You have to also get back the $100,000 into your pocket, right? So you're going to say, I plan to sell, 300,000 pieces of this over its lifetime. And so that means that I spend 100,000 to develop it. So there's 33 cents per product, to pay back all of this investment plus some, because the money you put in the NRE, first you put it in advance, so you've got to kind of account for a certain interest on it, and second, and most importantly, it's at risk because you might, for whatever reason, not sell any single unit of your product. But for sure you will have disbursed $100,000, right? And by the way, at the beginning of the project, you might plan for a budget of 20,000, and then as you discover more and more work, then after a while you say, well, my budget is going to have to be 100,000, and maybe in the end, once you have done everything, maybe it's 200,000 that you've invested, right? It tends to balloon as you really discover, as you work through the plan and you discover more and more stages. I mean, we often talk to people who come up with a new product, and and they ask us questions and they say, okay, but what exactly am I going to have to do? And then when you go into all the stuff they're going to have to do, the certifications and the tooling and so on, they're like, wow, maybe I need to redesign the product so it's much more simple. And that's really what we try to encourage them to think of. But yes, it's very hard to predict actually for people who don't have the experience of making that kind of products, right? Now,
Right.
everything I'm saying here is more for electromechanical products. Um, you know, B2B electronics, consumer electronics, various kinds of mechanical, hard goods. Now, if you're looking at, I don't know, shoes or garments, it's a little bit different. Of course, there are some one-time fees of, doing the design and selecting the right factory for that and setting up a standard and having the factory develop the samples and the size set samples and all that stuff and sending samples back and forth and maybe being there when they're starting to make the first bundles and really pay a lot of attention to the way they're starting things, and then it's done. It's really just recurring work. Typically for garment and shoes, it's much lighter, except if you're trying to push the envelope, with new technologies or whatever, new kinds of materials. But in 99% of cases, it's much lighter. But when you look at, I don't know, an iPhone, or it's millions of
Yeah.
dollars
Yeah.
spent in the just the investment of getting the product to where it can go into mass production, many millions of dollars sometimes, right? So yeah,
But
that
of course, Apple is projecting that they're going to sell, hundreds
yes,
of millions of pieces as well, though.
exactly, and they work with manufacturers that also believe in that. So the
Sure.
manufacturers also put quite a bit of resources, and yes, and they know they have a very well defined process for bringing these kinds of new products to the market in a very specific time frame and at a very specific quality standard also. Yeah, Apple is like one extreme, and people who develop their own product with a much smaller budget are kind of closer to the other extreme, of course.
Right. Okay. So now that we've spoken about what the non-recurring engineering costs are, do you have any examples of the typical costs that we might encounter for the different types of products or components that are likely to be made? You mentioned that initially you were talking more about electrical or mechanical products, and
Right.
of course that's something that we work with a lot. But I mean, there are a number of different processes used for production. So, perhaps looking at some of those, such as starting with plastic injection
Sure.
molding.
Yeah, sure. So if your product has internal parts or maybe the enclosure or both in hard plastic, um, most of the time it's probably going to be thermoplastic that are going to be injection molded into shape.
Hmm.
And that requires tooling, which is actually kind of expensive. And you don't want tooling that just makes 10 shots, or you want a tooling that makes at least 100,000 shots,
Right.
because it doesn't make much sense to go with plastic injection molding for very low quantities. And yeah, tooling is expensive. It is very often more than $5,000 US. It's often 10, 20,000 or more.
Hmm.
And for some products it's way over $100,000 if there's a lot of custom plastic parts, right? So of course, if you work with a supplier that already has the tooling for that, great, you don't have to pay for anything. And there's a lot of people hunting for you know um, suppliers that already have the tooling for exactly the kind of products that they want and the right kind of shape, because they don't want to pay all of that tooling and then have to sort of manage it. And then when you switch from one supplier to the other, you need to make sure that you're going to get your tooling back, and then you get it transferred to the other supplier, and you get the other supplier to do the trials again and confirm what exactly the parameter, the process window and things like that. So, but if you want your own custom shape, there's no way around it. You're going to want to have the tooling, the mold, right? So that's not cheap. If you work with metal parts, same thing. A lot of metal parts are cast, and cast, there is also tooling, basically a mold, and then some, clipping tools or whatever. But the basic idea is the same. You have some molten material that is pushed into a mold under pressure and cools down. Is the metal equivalent to a plastic injection molding. If your product is electronic and you want your own PCBA, meaning that you don't want to just go on, I don't know, AliExpress and find something that already exists and that already does the functions that you want. You want your own PCBA, for example, to optimize the power consumption and to have your own features and logics and so on. Well, same thing, you're going to have to have someone do the design of it. So also I forgot, for plastic injection tooling, for casting tooling, obviously you need first to have maybe an industrial designer design actually the parts, right, in CAD software and 3D into the details. Okay, and that alone can be a lot of money. Then you need to maybe double confirm it, maybe have it made with 3D printing so that you can actually touch it and see, how it feels and how it whatever behaves and how it would fit with the other parts and things like that. To refine it, you go through several stages of simple prototyping like this and learning and adjusting. And then once you're sure that, okay, this can be manufactured, you might want still a design for manufacturing review to confirm that yes, it can be can be fabricated without obvious risks, for quality, for whatever, for some other process issues. And then you need the tooling itself to be designed. Okay, very often the tooling fabricator will do that, but it's not just about buying a block of metal and then carving the holes into it, right?
No,
it's a little bit more than that. And then there's the trials to approve the tooling, and there's always fixes to make and so on and so forth. So when you add all of that up, it's a lot of money, right? That's what I mean. For PCBA, same thing. You need electronics engineers to do the design, the layout and the schematic, and starting with the block diagram. I mean, you need to go from the big picture down to the details of the design, and then there's some cost for the stencils, the artwork, the outline dies, and all these kind of things. That's more of the tooling, and then there's some programming setup also, right? The drill profile, what exactly is going to have to be picked, how and where, and placed where, the visual inspection and all of that. And this is done at the PCBA factory most of the time, but you have to account for that. Somebody's going to have to pay for it in the end, right? So these are three examples. Obviously, there's a lot of other processes. A lot of products are extruded, whether it's plastic or aluminum or other materials. There's other kinds of molding, like, for example, compression molding. I'm not going to cover everything, but different materials come with different costs. For example, if some of your parts are in silicone, the tooling is going to be much cheaper. Also, some of the processes that are going to be used for production have a big impact. If you, for example, if you want to have some plastic parts, let's say you have three options: 3D printing, machining, cutting it out with a CNC machining center out of a block of plastic, and doing plastic injection molds. Okay, the first one, 3D printing, starts with very little engineering preparation. Once you have your 3D drawing, anyway, there's very little you need to do. You just basically plug things, send it to the 3D printer, and with the right parameters, and it's going to churn out the part. For CNC machining, there's a little bit more programming maybe, but in the end, it's relatively minor and insignificant. And again, you're going to have the first part pretty fast.
Yeah.
However, these two processes don't scale well. It's going to be more expensive if you have to make 300,000 pieces. And then for plastic injection molding, it does take quite a bit more investment at the beginning, but it does come with a lot of benefits. You can have special texture on the surface of the product. You can go with very tight tolerances, 0.1 or 0.05 millimeter, on your critical parts. That should usually not be a problem, right? So there's always pros and cons, and the discussion should always start with how many pieces are you going to make, right?
But this is interesting to actually dive into such a critical early part of the new product development process, because if you are launching a new product, you've got to nail this stuff, and I suppose that if for many entrepreneurs the costs involved and in order to scale, perhaps it can get quite frightening. But if we're not thinking about it, then this has got a great impact on your final product cost and the delivery time as well, right?
Oh yeah, no, that's for sure. You need to plan all of this carefully. You need to plan it carefully. And we see people, a lot of people come to us after their project has gone into trouble. And sometimes they come to us first, and then we're like, okay, well, this is all the stuff you're going to have to do. And they kind of add things up, and they're like, there's no way I can finance this. Okay, let me look for another solution, because this guy's, is not going to work. So maybe they go with a manufacturer that says, yeah, sure, can do that, no problem. And then 3 months later, not much progress. The manufacturer just dropped the ball and is no longer interested, because they also discovered a lot of extra complexity. And then maybe they try with a trading company or whatever. They try to do it with some Upworkers to do the some of the design and some of the sourcing, and then they come back to us like, yeah, you were right. It is really going to cost us what you said, or even more, right? People just have a very hard time accepting that what they think is I don't know, $10,000 kind of little investment, a little bit of design. Yeah, maybe we need a tool, whatever, and then we just give it to a factory and it's just going to go into production. Then it balloons up to 100,000, and it's just not something they are they're ready for.
Yeah, big difference.
Yes, big difference.
Right. Okay. So to keep on the topic of costs, and bringing it back to something you said earlier about some manufacturers are trying to find suppliers who have already got, for example, tooling in place. So, I mean, these guys then, in effect, they've already paid the NRE costs. So presumably this is more appropriate if you're buying, some sort of ready-made products off the shelf. Correct. Or, white labeling some products.
Correct. So if you there's basically three kinds of products you can buy from China, Vietnam, Taiwan, the different places in Asia. Standard off the shelf means you can probably buy it from several suppliers, the exact same product with the same specs. Okay. So whatever, fasteners, certain batteries, and there's a lot of screws. So that, of course, you should not even think about it. You just you don't need to worry about the NRE cost. I mean, you're going to have some NRE costs if it's a significant part to you. You need to spend a bit of time to source. You need to spend a bit of time to qualify the supplier, maybe, to verify. Maybe it has an impact on certifications. You need to double check these kind of things.
For batteries, for example.
Yeah. They say that their cells are UL certified. Okay, to what UL standard? What exactly is it? Let me check. But as much as possible, you want to just push all of these costs back to the supplier. They pay for the certification, and then it's their product. You buy it, fine. Then there's the custom off the shelf, if I may say that. You buy it, it's already there, it's already been developed. However, you might only be able to buy it from one supplier. So they have already incurred the NRE costs. Now, be very careful. Their customer might have incurred the NRE costs, and their customer, another one of their customers, might own the intellectual property. And well, will the supplier tell you about that? Not always. They might say, yeah, it's fine. Yeah, of course you can buy it. Yeah, it's my product. Yeah, we've developed it. So this is the ODM model, original design manufacturer. Usually they call it ODM in China, where the factory already has something in their showroom, let's say, or these days it's more like their Alibaba page. And people say, yeah, I want this just the same. Make it in green with my logo, and the packaging would be like that, right? You need to be careful because it's not your product. You're basically a distributor. You need to be careful. If you design your own product using a component, a module, a sub-assembly that is custom off the shelf, you need to be careful. You need to have a contingency plan in case maybe that specific module, I don't know, goes end of life, or suddenly they are very unreasonable and the price goes ×5 or something like that. So there's a little bit of risk. However, you don't have to pay for the NRE costs. It's so tempting, right? Usually makes sense. And then there's the fully custom part, or components that will go into your product. So yeah, the very, very classic case, if you want your product to have a visual identity that's really unique, so you want to develop your own casing, your own enclosure for the product, right? So this is really a custom product part, and you're going to have to pay for all the costs. Now, if you work with a manufacturer that really believes in your product and really, wants to quote unquote partner up with you, and they can maybe do some of the design for free, and maybe pay for half the tooling, only invoice you half of it, you have to be careful. So it might be a great thing, might be great, but who will own the intellectual property of the product? Are you allowed to just take the product somewhere else? Will you have all of the design files and everything in your hands, ready to go? Will the UL certification be in your name? These are all kinds of questions. Will you have the visibility on all of the bill of material, or if you cut out that supplier, you have to resource all of the parts, and that might actually be a ton of work, right? So are you going to be hooked? Are you going to be in their bag, basically? Or can you really just go away at any time, right? So if you don't pay, you're going to end up paying for it anyway, because the unit cost will be higher, and in some cases much higher. There's pros and cons here, and obviously, it will depend on the project and the projected volume and things like that. If you want to have full control of your project, then it's better to work with a contract manufacturer. That's the general rule of thumb. However, if your volumes are going to be very low, it might not make sense for you.
Mm-hmm. Regarding the responsibilities and ownership of IP and who's actually going to be paying the costs of the NRE and all the rest of it, I suppose this is where agreeing on an enforceable manufacturing agreement at the very beginning of the project really comes into it.
Actually, a development agreement more than a manufacturing agreement, but yes. Right. And we've seen some. I mean, it can be a development and manufacturing agreement, right? Yes. This kind of agreement usually spells out who will pay for what, who will own the intellectual property, and what exactly does that means. It will usually spell out what information the buyer has to have at any point in time, versus the supplier can keep it in their pocket. But usually, if you want the information, you have to pay for the service of getting that information. And with a lot of manufacturers again, it's extremely common in China, very common also in Vietnam, and in Thailand and so on. If you are not careful, they will do some of the work for free, but you have to know that there's an expectation that, hey, you are not going away. This is sort of our product because we did that for free, right? So if you want to avoid that, you need to spell things out clearly in a contract in advance. And if the manufacturer, is, and most manufacturers are not that interested in doing service for payment. It's not their business model. Their business model is to go into production, make a lot of product, move metal, boom, and then ship out, get paid, and next one. That's their business model. Think of it as a big machine that never wants to stop. Yeah, and so you might have to hire your engineering team, to hire, some of the stuff yourself, or hire a service company that will help you with the product engineering and also with the supply chain side of it. Sourcing the components, qualifying the suppliers, checking on on compliance testing that applies, and all of these kinds of things. There's a lot of supply chain work to be done.
Yeah, but you're going to uncover this at an early stage when you're doing your sourcing and due diligence process and find out, what the true capabilities of the manufacturer are, if they're prepared to actually do that work, or even if they can do it.
Ideally, yeah. Ideally, but you can simply ask them, hey, usually how does it work? The customers bring you a full, look-alike and work-alike prototype, and they give you the specification sheet and checklist, and they even develop the testing jigs themselves and so on, or you take the idea from the beginning and then you work through the design and the prototypes and everything. Try to gauge what they're most comfortable with. The further down the line you are, the more appealing it will be to them. because it's just an idea and like, yeah, I need you to make a prototype for me, and that's it. Most manufacturers will not take you very seriously because they get 100 requests like that every day or every week, So it's not that interesting. However, if you say, well, I want to make this product, it's a little bit complex, but look, we have prototypes that are already fully approved, functional prototypes, and here's the specs, and and we're already developing the tooling, and we'll need a place to make it. That is more appealing because it can go into mass production faster, and once it's approved that factory is the supplier, there's a much lower risk that the project falls through, because a lot of the work has been done. Now, a word of caution: a lot of people, a lot of companies get to the point where they have a prototype that is maybe mostly functioning or fully functioning, and then they say, okay, great, we've done 90% of the work. Now we just need to plug that into a factory and they will just make product. Not that easy. In some cases, you haven't even done half of the work. Maybe you're 20% there, because maybe your design is going to be very hard to fabricate. It's going to make it very hard to fabricate some of the parts. Maybe your quality requirements would make it very hard to have maybe the right visual aspect on some of the parts. I mean, it's we've had cases like that where people say, oh, it's pretty much done, and we're like, wait a minute, on the supply chain side, you have a list of parts that you sourced on whatever, Amazon or Alibaba or something like that, and you want to buy 10,000 pieces from these guys, that you've never qualified or anything, not going to happen. There's some sourcing work to do here. Where's the certification? Oh, you haven't got FCC certification, really, and CE? What are you thinking? The tooling is not made. That's going to take at least 6 weeks once all the drawings are confirmed. And by the way, we look at your drawing, and there's these like 3 blatantly obvious issues that make it impossible to do plastic injection molding. And people scratch their heads and they're like, oh wow, it all looks so complicated now. And then, oh, how are you going to test this? Oh, we don't know. The manufacturer will know how to do that, right? Oh, you count on the manufacturer to tell you how they're going to confirm quality, and like you don't have an idea about that? Oh, okay. Interesting concept. So yeah, that's the common situation, let's say. To sum up, if you're developing a new product and you try to project the full costs, you gotta look at, on the one hand, the non-recurring engineering, including the design work, the sourcing work, and supplier qualification, and reliability testing and compliance testing, and putting the prototypes together, of course, first, and getting feedback from potential customers and redoing prototypes, and putting together quality plans, and doing fabricating the tooling, and doing some more testing, and so on, doing maybe the testing stations or special checking fixtures and things like that. So all of that is quite a bit of work, plus maybe lining up a good assembly supplier, negotiating a good contract with them, with a good lawyer. Okay, all of that is the one-time investment, let's say. And then on the other hand, you need to think of your recurring costs. So the recurring costs, if we add things up, there's the parts that are going to go into the product. So again, some of them are standard off the shelf, okay, it's relatively simple. Some of them are custom, but custom off the shelf. You don't have to pay for tooling, but some others are custom, and you have to, they might do the tooling and then amortize it in the unit cost. So this might be recurring. Again, we don't always advise people to do that.
Mm-hmm.
It's usually not in the interest of the buyer, but sometimes it does make sense. And then there's the cost of making the parts, with the material plus the processing plus the scrap and rework and so on. Then, of course, you have packaging. Some people don't think about packaging until sort of the last moment, and then they say, "Oh, I want really nice packaging like that," and then they pull out something like in an Apple store, where the packaging costs as much as the full product. So you need to think of that. The assembly, there's labor and all the overhead of the factory. They are going to have some scrap and some rework and so on. Then you're going to have to ship it, pay import duties, maybe tariffs and so on. Getting domestically through the distribution centers, or maybe you're going to drop ship some of them. I mean, you need to think of all that. And then once it's on the market, is that over or not? What about returns? What about warranty issues? And that actually can be quite costly. So, there's non-recurring and recurring. You need to make a distinction here. One thing I forgot, of course, in non-recurring engineering is the firmware, the app, whatever. All the software tends to be in the NRE category also.
Mm-hmm.
Even though you will still keep tweaking things all along, you might have 5 different versions of the software with a ton of little updates in between. So even by the time you have some products on the market, you still don't know the full extent of your NRE costs, because you will probably still have ideas on how to make the software better and so on.
Okay, so that's really finishing it off well with such a great summary, and also a bit of a look at the recurring costs as well, which I guess could almost be another podcast in itself. But yeah, this is all really, really good info. So thanks for sharing. Very, very helpful to anybody developing new products. As ever, there are related pieces of content that we've produced, like blog posts and other pages over time. I'll link to some of those in the show notes, so do have a look at those. So with that being said, Renaud, thanks for joining me, and thanks everybody for listening.
Hey, thanks. It was a good one.
Thanks for joining us. If you've enjoyed today's podcast, don't forget to like and share, and you can subscribe on Apple Podcasts, Spotify, and all other places that you get your podcasts from. See you next time.